So, good evening. So, good evening, one and all. Uh, so, today I am going to talk about how we can do recommendation system using datasets like movie recommendation system. Okay. So, everybody will know nowadays how the recommendation system will be working. Okay, even in Netflix or YouTube or any other like uh, any other platform, okay, like Facebook or Instagram. Okay, so we have a lot of social medias and lot of network uh, video channels, streaming channels. Okay, so based on that we know how it's working. Okay, based on your watching videos, based on your hashtags, okay, it will be give the output, that is it will be give the recommendation. Okay, so like that we will know about recommendation system, but how it's working in real time. Okay, so today we are going to see about that only. Okay, how we are doing this in real time. Okay, so today webinar is conducted by Bhoj Engineering College for Women. Okay, so the program is conducted by Bhoj Engineering College for Women. Okay, so with association with Pantech e-learning. So the webinar topic is deep learning in modern recommendation system. Okay, so deep learning in modern recommendation system. Yeah, it's one of the special day. Today I am very glad to take this webinar for the Department of IETE. Okay, so Dr. C. Murugamani, HOD of IT Department, Information Technology Department, and convener as a Murugamani, and then principal Dr. J. Madhavan, and then coordinator Mrs. E. Nitya, assistant professor IT. Okay, so thanks for this webinar association with Pantech e-learning, and thanks for the respected college, Bhoj Reddy Engineering College for Women. Okay, so today's topic is nothing but deep learning in modern recommendation system. So about before we enter into the session, I like to introduce myself. Okay, so I am Kamalesh. I am from Pantech Solution. I am currently working as a research software development engineer, like data scientist, machine learning, deep learning, and AI. Okay, so if you have any doubt regarding this webinar, you can contact me on hyd.java@pantechmail.com. Okay, so thank you for this wonderful webinar by Bhoj Reddy Engineering College and Department of IT. So let me enter into the session. So today, what is the goal of this session is nothing but I will tell you the introduction of the data set, and then I will teach you some how we can do recommendation system with cosine similarities, and then I will make you to predict some result. Okay, like based on recommendation we will predict some result. Okay, this is the main goal of this webinar. And the table of content, that is agenda, is nothing but first we will see about understanding how recommendation work. Okay, so in recommendation we have different type. Okay, so based on that how it's working, and then data set. Okay, what is the data set consist? Okay, because if you enter into the machine learning or deep learning or any type of projects, we need some data sets, so that those data set want to understandable, and then you need to know the each and every column and attribute. Okay, what is the data set content? Okay, we need to just introduction about the data set what we have data set, and then if you need even more about this data set, or you want to download those data set, in link I will give the description of those data set. You just click that, check the description, and you can download the data set. Okay, then what we are converting into 2D matrix. About this I will explain you in technical wise, and cosine similarities, measuring the distance between each users, and movies. Okay, so in this webinar we are using movie recommendation system. Okay, so our dataset consists of movie names and ratings. Okay, so about dataset I will explain you, then after that we will done the recommendation system, and I will show you how it's predicting the result. Okay, so this is the agenda we are covering in this webinar, and let me enter to the session. Okay, so first one is understanding how recommendation system work. Okay, so about recommendation system, if you take generally Netflix. Okay, so Netflix is one of the now popular one and most trended one, so we can take it as an example as a Netflix. Okay, so in Netflix definitely you will be search for movie like Black Panther. Okay, or any other movie names, like any Hollywood movie names, or Tamil or Telugu or Hindi movie. Okay, so you are searching with titles only. Okay, so in Netflix we have another options also. Okay, for example, you want to see any science fiction movies, means you can directly search it in science fiction movies like that. Otherwise you want to see any romantic type of movies, means you can directly type in search bar romantic type of movie, means it will be automatically give the result. Okay, so like this you are searching for one heading. Okay, so those according to those heading it will be give the result. Okay, so how this is based, means this is based on the data. Okay, so if you are uploading any movie to the Netflix, they will use some hashtags. Okay, so this movies will be an science fiction movie, or recommendation movie, sorry, or romantic movie, or love movie, like that they will use some hashtags. Otherwise based on the users, okay, user rating, it will be give the result. Okay, so like this we can do in recommendation. Okay, that is called recommendation. Okay, so based on the previous history, it will be give the relevant content to you. Okay, so that is called recommendation system. In recommendation system we have different type, like user based and item based. Okay, so user based is nothing but they will call us technically some other words. I will tell you what is the technical word, but if you if you see the title user based, means name itself suggests is there how the person will be using. Okay, what type of person will be using those kind of things. Okay, based on that it will be give the recommendation. Okay, for example here you can see we have two men. Okay, one men, both are similar only, both are related to sports persons, sports person. Okay, so some person will be one guy will be eat like pizza or any other vegetable items. Okay, like same thing another guy also using vegetable items. Okay, you eating vegetable item. Okay, so both are taking vegetable items, but another one guy extra they will take like energy drink. Okay, so energy drink for sportsman, energy drink is important, so automatically based on the user based it give the recommendation. Okay, so for another one person, that is for light blue shirt, it's automatically give the recommendation. Okay, so you it's possible you can take an energy drink. Okay, because another sportsman is using energy drink, so they automatically recommend. Okay, this is user based recommendation system. Okay, so if you take an item based recommendation system, you can see here based on the company. Okay, so first one guy buying an one tin. Okay, one tin of juice or anything, energy drink or anything. Okay, he is buying this based on the brand of Dept. Okay, so automatically for the user, okay, for the who buy that user, automatically it's similar to the same, that is automatically same company, based on the Dept company, the t-shirts also available, they automatically recommending the user. Okay, so it's like an if you are buying a mobile in online. Okay, during ordering time it will be give some suggest you can buy headphone or or back case, okay, or any other thing, charger, okay. So like this it will be give the recommendation, it will be useful to you like that, okay. So this is called item based, okay. So totally we have two types, okay. This two type is called as an, in technical word, collaborative filtering and content based filtering, okay. So collaborative filtering is nothing but what is the example first we see, that is user based filtering, and then content based filtering is nothing but item based, okay. So in technically they will call as a collaborative filtering and then content based filtering, okay. So this is the detailed example, okay. So both are similar user, read by both users, okay. So automatically for both of the users it's recommending, and then another side we have a content based filtering, okay. Today webinar session we are going to see about collaborative filtering, okay. So before we go entering into the session, I will tell you dataset consists, okay. So here I given a link in a description itself, okay. You can check, you can click that link and check the dataset, okay. So I will give the some description about dataset, okay. So dataset consists of 1000 rating, that is 1 lakh ratings, and then 1 to 5, that is 0 to 5 star rate, and then totally we have 943 users, okay. 943 users means 943 users rated some movies, that is how many movies is 1682 movies, okay. So totally 943 users rated the movies 1068 movies. Each user has a rated at least 20 movies, okay, at least 20 movies. And then simple demographic information about user is nothing but age, gender, occupation, like zip file we contain in that dataset, okay. So this is the simple understand about dataset, okay. Dataset consists of this thing, okay. Then we enter into an Jupyter notebook or Google Colab or Kaggle notebook, okay. So about notebook, in yesterday videos I told about how we can use a notebook in different manner, okay. So if you are not installing Anaconda Navigator, you can use Google Colab, otherwise you can use Kaggle notebook, okay. So let me enter into the notebook. So I already have a code, but I just tell you how we can do with import as PD and import numpy as np, okay. Then from scalar dot metrics, about this I will tell you. Metric is nothing but we just if you want to find the classification report or accuracy report or confusion matrix, like that if you want to do means you can use metrics, okay. So from metrics I'm importing pairwise, okay. So metrics pairwise, import pairwise distance, okay. So about this I will tell you what is the uses of this, okay. So I am importing totally 3 packages. One is pandas, it's used to read the data set, and numpy numerical python, and scalar importing a pair distance, okay. About this I will explain you, okay. Then after that I'm giving a header, okay. So I will show you the data set. Here you can see this is my data set, okay. So here I can get gender information and then item information. Item is nothing but movie names, okay. So here today we are going to predict the movie prediction, okay. So movie name and then test data, okay. So like this only I'm having. I am my data set in not in the form of any CSV file or any Excel file or text file. I'm having only a data, okay. So we need to read those data. So for that purpose there is no header file, so I only giving an header file, okay. So the main aim of the project I will tell you. movie recommendation. Okay, so if you enter the any movie like Marvel related or Batman, okay, if you enter any movie, okay, so it will be give the suggest movies like Batman. Okay, so for example, if you enter the Batman, like Batman, what are the movies are available in dataset, it will be give the suggest, we can watch like these movies and all. Okay, so this is the main aim of today's webinar, movie recommendation. Okay, so here I am creating a header is nothing but uh, the data content without header, so I am creating here header. Okay, first one is user ID. Okay, so user ID, and then item underscore ID, and then rating. Okay, so how much it's rating, next column, after next column time stamping column. Okay, so this is the header. Okay, that is column wise. Okay, first column will be user ID in my data set, and next column will be item ID and rating and timestamp. Okay, next I'm importing a movie lens data. Movie lens. Okay, so this data set is downloaded from movie lens, so I'm using the variable name. Okay, so it's our wish only, you can use any variable name, not a problem. So I am calling a pandas to read the data set. Okay, to read data set. Okay, so those data set will be available in the folder like code. So this is my IPNB file. Okay, my dataset will be available in this ML-100K. So what I will do means I will give the name of the folder MLK and then hyphen. That is, after entering to the MLK, I want to read U data. Okay, this is the main data. I want to read U data. So I am entering a U data here. Okay, then after that I already using here header. Okay, automatically header will taken, no need to initialize the header here. And then after that I want to do separate comma separated value. Okay, so separate function. Okay, so each and every in new data, each and every column will be separated by tab. Okay, tab space, so I am using here tab. Okay, then after that names equal to header. Okay, so I already initialized the header, just I am calling the header. Okay, so I am running the cell. Okay, it's run properly. Now I am trying to display the output, what it will be happen, let's see. Okay, see here, so user ID, item ID, rating, timestamp. Okay, so user ID, item ID is nothing but movie name. Okay, 242th movie name and 302th movie name and 377 movie name. Okay, so belongs to the movie name, this ID, and rating. Okay, rating is nothing but this 242th movie will be a rating 3. Okay, that is we can one time watchable. Okay, so 1 and 2 means it's not very poor one, like that. Here I am having a movie ID and rating of that movie. Okay, so now I read my data set. Next I will check the save some information. Okay, about data set. Okay, movie lens data dot save. Okay, so totally I have this much rows and this much columns. Okay, so if you want to find a unique queue, okay, like I already told to you, we have n number of users, like 943 users and 168 movies. Okay, that is n number of users and n number of movies. Okay, so if you want to check also, we can check it in here itself. Like you can use n underscore users comma n underscore movies. Okay, so here I am calling movie lens data, and in user underscore id. Okay, I need to find only a unique. Okay, I need to find only an unique. So that is, we need to call the function of n unique function. Okay, so just click the tab button, so automatically give the suggest. Here you can use n unique, then like this. Okay, so if you want to find and same thing for n number of movies, means just copy it and then paste it. Okay, instead of user id you need to change item. Okay, so item means about item id, item underscore id. So here you can see item id. Okay, just I am checking for unique. Okay, so it's according to the dataset, it's currently it's having or not, I am just checking. So next I run the cell. Next, if I print the variable, here you can see 943 and 1682 movies. Okay, so as it is, what we have information in the dataset, 943 users and 168 movies. So same we are getting here, 943 users and 168 movies. Okay, so this is the way we can find an output. Okay, so next what we have to do means, next thing we need to find an we need to train the data. Okay, so we need to train the data, we need to convert those data into zero, um, like zero rows and columns like that. Otherwise I will tell you, wait a minute. Okay, train, okay, underscore data underscore matrix. Okay, so here I am converting into the 2D matrix. Okay, so I already told to you what is the 2D matrix. Just I will explain to you what I will do in next step, converting into 2D matrix. So what I will do in converting into 2D matrix means, whenever movie I have a user, I have seen that values for that user will be. Okay, that is, whenever I have a user, and I have definitely have that item name also. So for example, you can say take, let's say user A have watched 5 movies out of total 1068 movies. So what I will do means, I will take it as a separate row. In that A as a separate row, according to the item ID. For example, A watched 5 movie, right? Okay, so A watched 5 movie. Okay, so according to the A, I have totally 1682 columns. In the 1682 columns, how many movies watched by A is 5 movies. Okay, that is in 1682 movies, totally A will be watched 5 movies. So what I will do means, that 5 movie represented column will be a non-zero, and remaining all will be a 0. Okay, so that is what next I am doing. That is called converting into 2D matrix. Okay, converting into the 2D matrix. Okay, so I will go enter into the. Okay, so here I am np.0. So numpy have one function, that is 0. If you enter np.0 means 0, how much 0 time it will be create an 0 0 0 0 up to this 1068 time it will be created in single row 0. Okay, so that is 0. So if you want 1 also, you can use instead of this 1. Okay, it's not a problem. Okay, so here I'm doing with zeros. Okay, but in numpy we have only zeros and ones only we can do like this, not another any other numbers. Okay, then here I am calling n users. Okay, and n movies. Okay, I am taking n users and n movies. Then after that I am creating one for loop, and then I will use line, and then movie lens underscore data. Then I am using iter. Okay, iter tuples, because my data set in the form of tuples, so I am using iter tuples, then height colon. Okay, so here I am training a matrix. Okay, so what I will do means I will give the line. Okay, line 1, then -1. Okay, then line 2, I will show you the output, then you will be get an line 2 is equal to 2, then -1. Okay, equal to line 3. Okay, so this is the way I will create an 2D array. Okay, 2D matrix. Okay, so if I print the shape of the matrix, you will be get an comes to know, understand. Okay, so here you can see shape like, wait a minute, I will print the train data matrix. Okay, see here. Okay, so from I'm having a 0. Okay, totally I having a total number of zeros is 1682 zeros. That's what in first row you will be take a first row means the first row contains 1682 zeros. Okay, in that 1682 zeros, the respected user how many time watched a movie, that is 5 movies are watched means according to that 5 movies column it will be placed the rating. Okay, so totally here according to this first 5 I am getting a 5, 3, 4. Okay, so these are the rating respected movie column name. Okay, so this is the what I am doing with this program. Okay, so after I am converting it into 2D matrix, next I will move on to next step. What the step is converting into an distance. Okay, that is using similarity function. I will convert into the cosine similarity function. I will convert it into the function. Okay, so what is cosine similarity? I will explain to you. Okay, so cosine similarity to measure the distance. Okay, so why I am using cosine similarity means here cosine similarity will be comparatively good to predict the vector oriented. Okay, compared to Euclidean. Euclidean is nothing but if you use k-means type of algorithm. If you, for example, if you have a data set, the data set without any label or any output like that, without any label, you need to find an label, how many labels are available, that is how many clusters are available in the data. Okay, so for that purpose in k-means algorithm they will use Euclidean. Okay, but it will be mostly applicable for like that type of data set only. Here I am having a data set of like movie related only, so I will use I am having a vector form. So using this vector form itself, using for vector form cosine similarity is better, so I am using here cosine similarity. Okay, so cosine similarity formula is this one. Okay, like a dot b and bar a bar b. Okay, so this is the formula for cosine similarity. Okay, so here I am using a cosine similarity function to predict the distance of each data, that is according to the user how many users will be printing the result. Okay, so if you see the next slide. Okay, so here I am converting into the two type of distance. One is user distance and another one is movie distance. Okay, so user distance is nothing but distance of user with every other user. Okay, distance of movies with every other movies. Okay, so I will explain you in picture format, then you will be comes to know. Okay, so here distance is nothing but here you can see the picture A, B, C, D, E. Okay, so A have some skill, B have some skill, C have some skill, D have some skill, and E have some skill. Okay, so here you can do with this data itself we can do recommendation. Okay, like for example A will like reading books. Okay, so reading books or computer, I don't know. Okay, we'll take it as a book. Okay, so reading books, and then shopping, A will not like shopping, and B will A will like to hear songs and playing games. Okay, so like that each members will doing some activities. So I am taking a data up to D. Okay, now you comes into the E. Okay, so in E we need to find he will like those guy will like listening music or not. Okay, so what algorithm will be do, it will be check for previous data. Okay, so previous data who are liking like reading and shopping is C. Okay, so we will reading and read shopping, and then we also do shopping. Okay, so here we have some similarities. Okay, so this is called distance between both B and C and E. Okay, so when we comes to know both B and C will do not like to hear music. Okay, so that's what here automatically he will give suggestion as he will definitely not like music. Okay, so like this it will be calculate based on the distance. Okay, so instead of this ABCD in our data set, it will be an user. Okay, and then that column will be an movie names, like instead of reading we have some movie names, instead of shopping we have some movie names, instead of music hearing headphone, that symbol is some movie names. Okay, totally we have 1360 to something movie names will be, columns will be there, and then users will be there. Okay, so this is called distance. Okay, so now we need to calculate the distance of user distance and movie distance. So let me enter to the technical session and then we'll see calculate the distance. Okay, so to calculate the distance we just need some wait a minute. So user distance here, I'm just copying this. Okay, so here you can see I am passing this train data matrix to here, that is pairwise distance. Okay, so we need to calculate the distance. So I already imported the calculating distance using sklearn. Okay, so sklearn in metrics I am using pairwise function. In the pairwise function I am calling this pairwise distance, paired distance. Okay, paired distance means according to the user and movie name. Okay, how much distance between those is there. Okay, so if you are a little bit confused, you can assume this picture, you will be getting one idea. Okay, so we are doing like this only. Okay, next steps. Wait a minute. Okay, so here you can see using metrics I am calling cosine similarities, and then I will those pairwise distance function and cosine similarities function all are saved in user distance variable name. Okay, so then after that I will do for next train data matrix dot t. Okay, so everybody know about transpose matrix. Okay, transpose matrix everybody will know. Okay, so for example it will be give the alternative words. Okay, like if you have any matrix, okay, it will be converted into an some other, that is a copy of that matrix. Okay, so for example if you have a matrix with input 1 2 3 4 5 6 and 7 8 9. Okay, if you do transpose matrix means it will be all the rows will be converted into the column, all the column will be converted into the rows. Okay, so here I am doing like this only. Okay, so about train data matrix you already know. Okay, so I am using this, I am converting into the transpose matrix. After converting into the transpose matrix I will be fit into the transpose matrix into the pairwise distance function. Okay, then I will be get a movie distance. Okay, so user distance without transposing the matrix and movie distance with transpose the matrix. Okay, so about what is user distance and movie distance I already told to you. User distance is distance of user with every other user. Okay, so user distance, distance of user with every other user. Movie distance, distance of movie with every other movie. Okay, this is the difference between those two variables what I am here. Okay, so this is the two variable I am running the shell. Wait a minute, pairwise distance is not defined. Okay, okay, so here we imported after importing I need to run the pairwise distance. Okay, so what is the mistake is I didn't convert the pairwise distance into one function, sorry, into one variable name. So it's showing a error. What I have to do means okay, user distance, okay, user pairwise distance not defined. Okay, I will import. Otherwise you can do like this also. Let's we check. Okay, so instead of this matrix I am cutting that, and then here I am pasting. Okay, so I am running the cell. After running, pairwise distances equal to pairwise dot pairwise distance and function type error missing two parentheses. Okay, otherwise here we can do like this. Undefined. Moving distance. Okay, so instead of this you can copy this and paste it here, then dot. Okay, so we can do import like this also. Okay, so I am running the cell, so it's running. So totally I am having how much pairwise distance I am displaying here. Okay, so this is what, if you print an user distance, you would be getting according to the user wise what is the distance of each data. We can't understand, but it will be the what is that, cosine similarity between user distance and movie distance. Okay, so this is the what we want to do. Okay, so now it's all done about movie distance and user distance. So next step is we need to do some normalizing. Okay, normalizing is nothing but we need to convert our user distance. Okay, we need to we need to minus user distance and movie distance. Okay, that is called normalizing. Okay, so I just doing normalizing, that is 1 minus and 1 minus. Okay, so after I am done this one, I am save it in one variable, that is user underscore similarity, SIMILARITY. Okay, so same thing I will do for next one, that is movie similarity, movie underscore similarity. Okay, so here I just minus the user distance and movie distance and save it in one two new variable. Okay, so after this I will be apply the movie index. Okay, so till now we are looking, we have only an index of that movie, that is ID of that movie. Okay, so for example 242 means 242 have some other name like Toy Story or Four Rooms or Get Shorty, like that movie will be represent, but we are using till now name, index name only. Okay, so here next I will be do for attaching my movie name with according to the order of name. So here I am using this one. Okay, so IDX2 movie. Okay, I am IDX2 movie. Here I am running the cell. Okay, so after running the cell, it's run. Okay, so if I display the movie, like for example I want to see the movie of I want to see the movie of 0th movie name. Okay, what is the 0th movie name means? You can see here Toy Story is my 0th movie name. Okay, so if you want to find any other movies like 35th movie or 45th movie, exotica. Okay, so like this I am getting an output. Okay, Pulp Fiction. Okay, so all the movies now will be in here. I will converting into all the movie index name into the according to the movie name. Okay, so that is the what here we are doing. Okay, so next step, uh, you can find even, for example, here you are getting the Pulp Fiction in 1994 movie. Okay, so if you want to see movie index name also, you can see. Okay, movie to index, index to movie, movie to index. Index to movie means what you are giving a index number, it will be give an output movie name. Okay, so if you are giving a movie name, it will be given an output index name. Okay, so for example, here I am passing the fiction, Pulp Fiction. Here, wait a minute, I am passing like this. If I run the cell, I am getting 55. Okay, so you can see here both index value and movie names are both are same, matching. Okay, so this is what here I am doing in this for loop. Okay, so next I will be enter into the prediction result. Okay, so what we have done up to we done. Okay, now we need to check it's giving recommendation correctly or not. Okay, so for that purpose I am entering my, I want to enter my favorite movie. Okay, like that favorite movie only I need to see, I want to see in future. So I am creating here favorite. Okay, movie name, enter the favorite movie name or anything. Okay, okay, so here I am passing my favorite movie name, like what we will see. I like the movie, um, okay, Batman. Okay, Batman also I will like. Okay, I will use Batman. Okay, Batman forever. Okay, so I want to predict according, this is my input data. I already watched the Batman movie. Okay, so now uh, I like that movie, so I need to recommend like this movie in I want to watch in future. Okay, so I am entering my suggest list. Okay, like Batman forever. Okay, so it will be released on 1995. So it's case sensitive only because we are not doing real time. So I am giving all the things. Okay, then after this I need to related to the Batman Forever movie, I need some suggest list. Okay, so I enter the data, then I am calling the movie index. Okay, so mo movie underscore index, I am creating a movie in the underscore variable. In this I am passing movie to index. Okay, I already have movie to index. Okay, favorite name, favorite name. Okay, so then we will, if I print a movie index, you will be get an output what is the favorite. Okay, so what is the index name of Batman Forever? So index name of Batman Forever is 28. Okay, so now I will get the output. Then I need to predict some top 5 movie related to the Batman. Okay, okay, so top 5, here I am creating on how much movie. Okay, how much movie you need. Okay, I need top 5. uh, okay, so I'm creating one variable. In this I am passing 5. Okay, so top 5 I need as a Batman Forever, I need top 5 movies, some other related movies. Okay, so I'm passing here movies. Okay, movies equal to top. mm, Sorry, here we need to give top. Okay, similarities, this function. Okay, I forgot to inside this function. This is important function to predict the result. Okay, so what I will do before this, I will run this. Okay, So see here I am creating one function. In this I am top k movies. So top k movies I am passing three parameters. One is similarity parameters and mapper parameters and movie id k, that is movie index name, and k is equal to 6. Okay, so if you need means you can reduce the movies also, displaying movies also. Okay, so according to that it will be passed the into the function, then it will be run. Okay, so here I'm running the cell. After running the cell I just need to predict the movies, like according to the given movie I need to predict the result. So here I am passing top k movies. Okay, so I am calling the function name, that is top k movie function name. Okay, after I am calling the top k movie function name, here I am passing movies similarity. Okay, and then comma idx similar to movie, then comma idx to movie index. Okay, sorry, movie index comma k is equal to how much movie. Okay, so k is equal to how much movie. I already defined that how much movie I need, so I am passing k is equal to how much. Without you are passing k, it will be take it as a default output. Okay, so I am passing this one. Then after this I want to print, okay, how much movies I am displaying according to the Batman Forever I want to plot. So here you can see how much movie plus 1. Okay, so if I run the cell, movies not defined, sorry, here spelling mistake. See here, so if I run that cell, so I am entering a Batman Forever, I need like this movies for my suggest, so automatically it's giving a result Batman and Batman Returns and Cliffhanger and Demolition Man and Stargate. Okay, so totally I am getting a 5 movies related to Batman Forever. Okay, so this is the recommendation. Okay, according to my entering data, even I am entering the Batman movie name. So according to the Batman movie name, what are the another movies are available related to the Batman also, it's giving as a top 2, and then again 3 will be related to that movie also, it's showing. Okay, so if you want to check even more any other movie name also, you can enter. Like if you want movie name like Star Wars. Okay, here I am ready Star Wars, but it's case sensitive, you need to define correctly. Okay, so that is one of the problem here. So 1977 Star Wars movie, my index name is 49. So here you can check Return of the JD, okay, Rider of the Lost Ark, Empire Strike Back, and Toy Story, Godfather. Okay, so these are the movies, okay, related to the Star Wars. Okay, so now it's predicted recommendation correctly. Okay, so I hope everyone will understood this recommendation system. Okay, it's coming nicely. You can check it out this in your notebook also. After this webinar I will upload a program in my GitHub. Okay, you can download it. Okay, about dataset I already told you, sorry, I already given in description. Okay, you just click the description and download the dataset. Okay, so if you want to download the dataset means you need to create an account in your Kaggle website. Okay, then only it will be download. Okay, so once again I am just showing the code. Okay, so this is the code for recommendation system. Okay, so here you can see unique ID, and then you can just type it, that's enough. Okay, so these are the code, cosine similarities. Okay, and then next this one, and then this is the code. So code also after this webinar I will upload you, okay, in my GitHub channel. You can just check it. Okay, so this is what recommendation system. Okay, so based on that we are recommendation we are predicting. Okay, so what is the main thing we are doing here means cosine similarities and distance. Okay, distance of each user and movie distance. Okay, so this is the main area. So let's we covered about recommendation system, and also we studied about concepts like collaborative filtering and content based filtering. Okay, so we have covered everything. If you have any further more information you can ask it in the comment section. I will reply you. Okay, I will reply you. Any question is there you can just ask it in comment section. I will reply you. Okay. And one thing about attendance link, okay, each and every time we will post in comment box also, and in description also we have. Okay, if you are see the link, you can just click that link and fill the attendance link. Okay, so if you are new to this channel, please subscribe the channel and hit a bell icon. Okay, so you will be getting notification each and every time. And then if you like this video, please hit a like button. Okay, so you will be get a it will be useful for us. Okay, please hit a like button and share to your friends also. Okay, any doubt in if you have any doubt, please ask it in your comment box. Okay, I will reply you. Three minutes more. If you have any doubt, please put it in comment box. Very nice session. Thank you. No, here I am not using any Keras and TensorFlow. I am using just cosine similarity in SQL. Okay, so the title is deep learning in modern recommendation system, but I am not using any deep learning packages. Okay, very. Any other doubt, please check. Okay, thank you. It's time to signing off. Okay, so we are connecting an internships also. Okay, like Pantech internship program like IETE. Okay, so if you are willing to join with us, you can join like titles like deep learning or machine learning or electric vehicle and application or Arduino or cloud. Okay, so we are connecting like 1 month or 5 month 5 days internships also. Okay, at last I will show you some numbers. Okay, you can call to the numbers and you can register for this internship. Okay, and then thank you for this wonderful webinar session by Bhoj Engineering of College, and thank you for IT department, okay, to connecting this wonderful webinar with Pantech e-learning. And once again thank you by Kamalesh S. Okay, so if you have any doubt regarding this webinar, you can contact me on hod@pantechmail.com. And if you want to know any other upcoming event or further more information, you can contact me on WhatsApp like 7010 888 841, okay, 841. And then Telegram channel we have Pantech e-learning, okay. It's, if you are in Telegram, you can join with us. And then thanks for this wonderful webinar. And if you want to register for your webinar, sorry, you register for your that IETE program, okay, so intensive program, you can contact those numbers, okay, Senthil Kumar, Srinivasan and Kumarasamy, okay. So you will be register using they will help you, okay. So thank you guys, I hope everybody will enjoy the recommendation system, how we can do using question similarities, okay. And we will see in another one new video guys. Thank you. It's signing off from Kamalesh. Bye.